Hello everyone, this is David again in another Ubidots Facebook Live. Today we're going to be talking about how to integrate with TTN, that is the Things Network, is a network service provider for the LoRaWAN network. Here with me is also Maria, our content manager and hardware engineer, who will be explaining us all of the things we are going to manage. Both uplink messages and downlink messages, and I'm going to let her present herself, and then just a quick question for her before we start presenting all the things we have planned for today.
Thanks, David, for your introduction. Welcome again to this new Ubidots live session. It's a pleasure for me being here talking about IoT knowledge. So we can share this kind of space that we can share all together. So if you have any comment about what I'm going to be explaining, just let your comments in the comment section, and I will be happy to answer your question. Basically, today we're going to be explaining the management of uplink and downlink messages using the Things Network and Ubidots. The hardware configuration. But anyway, I want to show you how to make the basics as how to set the credentials in the device with a sample code that I already write. And I'm going to provide you guys a basic step-by-step written guide that you can follow later if you want to replicate the same demo that I'm going to be demonstrating today.
So before we start, I just have a quick question for you, Maria. I know we recently were in the Things Network conference in Amsterdam, and you were there.
Yeah.
So I just want a quick summary of how you felt if you get to know people and new projects that it surprise you, people doing cool stuff with IoT.
Yeah. Well, basically, being there in the conference was a really great experience. I meet a lot of people working in different kind of projects, that something that you sometimes you don't imagine. But basically the thing that I love the most is see the community part of all the Things Network side, like how everyone is helping each other in order to grow the community all together. There are different projects like for save battery life of our devices, to handle a more range for our communication. There are some projects for wildfires and also for wildlife animals. I recommend you guys just reference to the Things Network YouTube channel, where you can find all the talks about all the keynotes that went there.
Great, thank you, Maria, for that quick summary. And if you don't mind, we're going to change our screen. We're going to start sharing our screen to show both Ubidots platform and TTN platform, as well as us explaining you guys. So yeah, Maria, go ahead, please.
Okay, cool.
While we change our screens, I just want to make a brief comment about the hardware we're going to use. Right now, we're going to be using a SODAC 1 version 3 device, which is able to connect to a LoRaWAN gateway and then forward messages to TTN. So I'll leave Maria and I'll be stepping in and asking her questions, so you guys have everything very clear.
Okay, so let's get the start. The first thing that we have to do to start creating our application is just go to the Things Network platform and go to the application side and create a new application, right? So to create a new application, just press the Add Application button and assign a name, an application ID for the application. In this case, I'm going to assign app_Ubidots as application ID.
Yep.
And description, we can say Ubidots live demo, and then we have to assign the region where we're going to handle our application. In this case, in our case, is US West, because we are in this zone. It didn't change.
This is related to the frequency we're going to use in our hardware, right?
Yeah, exactly.
Okay.
In the zone that we are located at this moment.
Great. So I think US West means 915 megahertz, right?
Exactly.
Okay. Yeah. So you guys need to be really clear about this. So where you're deploying your application, and then select the properly frequency on your zone.
And also the frequency for your zone and the zone that where your gateway are deployed to, because you have to be careful with that, because probably you have your gateway configured with another zone, and you will not able to establish the communication between your devices, between your application and your gateway.
Okay, great.
Okay, now that we have the application created, we have to register some devices in order to start sending data to the things network, and also to start receiving data through this device. So the first thing that we have to do is register a device. But here we need a credential that is provided from our device, which is the device EUI, right? So this is a unique identifier for each LoRaWAN device, which is unique per device. So in this case, as David already told you guys, we are going to be using a SODAC 1 version 3 board, and in the SODAC documentation you can find a basic example, which is to transmit data directly to send commands directly to the module, LoRaWAN module. So in this case, I'm going to upload this sample code into the board in order to be able to send commands to the module to get the hardware EUI of the module in order to be able to register it in the things network. So the code I already finished the upload, and here I'm going to assign the command, which is sys get hardware EUI. So here we have it. This is my unique identifier, which I'm going to place in the device EUI section. Also, I'm going to assign a device ID, which is going to be SODAC 1
version
V3, right? And the application key and the application EUI are going to be automatically generated by the things network. So we just have to press register. At this point, you can see that the device is never seen because we are not sending data at this moment. But now we have to set these credentials in our board with our firmware, with the uplink messages configuration and downlink in our case, because we want to demonstrate both of them in our firmware. So we are going to set this credential. This is another sample code that you can find later in the written guide that I'm going to provide you guys. So basically here we have to replace the credential of our device. So I'm going to take the credentials. This is a sample code that you can just replace it here, and that's it. Here, as you can see, let me verify that are the right credentials. Okay, no, are not the right ones. Let me be carefully copying this, and then we place it. Here we have it. Then after you assign the credentials, you have to take care about the zone, that where you are placing your device. In our case is 915 megahertz, right?
Great.
So now we just have to check our code in order to verify that everything is right. Here basically we are just handle the join request to our gateway, and we are configuring some sensors and actuator. Well, a sensor and actuator, which is a potentiometer to send an analog input from the device, and also we have an actuator, which is a relay, in order to control something with our downlink message, right? So here, after verify the code, we're going to upload the code into the board. So we're going to wait for a couple of seconds until the upload finish.
Okay, this is taking longer than expected, but is this usual with Arduino?
Yeah.
I just want to refresh and take this opportunity to make a little comment on the code. This is all going to be available in a guide we're going to publish in our community, blog, and help center. This code basically just reads an analog port from a potentiometer, and we also going to control a light bulb. Later on, we're going to show how to manage downlinks. In the meanwhile, maybe do you think there's a problem with the...
Yeah, I am closing the serial monitor. I think that is the problem. Let me open it again. It is not a problem. We have the right credentials already here. We'll just upload the code again. Yeah.
Let's go.
We have it.
We have it. Okay.
So if I open the serial monitor here, you can see how the device is handling the join request, and in a couple of seconds you will receive that the join was accepted.
Great.
So at this point we are sending data to the Things Network.
So what do you think before we step on the TTN's platform?
Okay.
So people, I just wanted to show you how the reading is changing. Now we are sensing 1023. It's just an analog value. Then if I turn our potentiometer, we're going to see a change on the reading. I just want to clarify
that the loop of the second is every 10 seconds.
That we are looping on our code every 10 seconds because TTN advises to do that way in order to prevent message lost or saturating the network. So as you can see there, we have now 544 and we're going to see it right now on TTN platform. If you go to the application and you click on data,
let me refresh the page because the status is never seen and we already are connected. So here you have 8 seconds ago.
Great.
So this is going to be updating every time that the device is sending a data. If you see, we have 3 seconds, and when it reaches out to 12, it's going to return to 1 again.
What do you think, Mari, if we go to the actual app and then go to the data?
Okay, cool, no problem. Here we have an application data, and then we are in the data.
There it is. So we have right now 2 packages. It is not de-encoded right now because it's being sent on X values. And I think what we're going to do right now is decode it.
Exactly. The next step is build a custom payload in order to send this data in the right format allowed by Ubidots, right? Which is a JSON file.
Yeah.
So for this, we're going to the payload formats. We select custom, and then in the decoder, we're going to write our decoder code, which is basically, let's define a variable, which is going to be our value of our decoded value, potentiometer.
So guys, just to warm up, this is something TTN already offers in their platform. It's a way to decode data really easily. Because all data needs to be sent on X encoded data. What we are doing right now is decode it to convert it to an integer value that it will be received by Ubidots. It's just some bitwise operations to convert from X values to integer, and then we're going to build a JSON according to our Ubidots API. That is really easy. It's just a JSON stating the variable label. Don't you think it needs double quotes on the variable label?
No, it doesn't need it. Here also we can test it here in the payload. So if we assign any value, let's say this one, it's going to be converted and it's going to send the potentiometer variable with the expected value, which is the one decoded in this.
Can you test a value we know, like something, for example, 03FF? I know that is 1023.
Yeah,
our maximum value. And so that's correct. Great.
So then we save the payload function, and once the payload function is safe, and our device sends a new dot, we should be able to see we have to see our new device in our Ubidots section. So if I refer...
Not yet.
Yeah. No, sorry.
There is a step
I a step more, sorry. So we have to integrate this data with Ubidots. So
before that,
okay.
Guys, we have an update there. Can you go to data, please?
Yeah, of course.
Because I want every user to see all the steps from the Arduino serial monitor, then TTN. I just moved the potentiometer. We have now a reading of 1023, and then you see it on TTN. Now what we're going to do is just what Maria said. We're going to integrate this data to Ubidots. This is going to be done with the tab integrations.
We're receiving a comment over there, which is the volume is too low.
Okay, Santiago is telling us that the volume is too low. So if you excuse us just a second, we're going to check on. Maybe Maria, you can see on the program we're using for.
Yeah, let me check.
So we are right now looking at what is possible to do, but this is really weird because the volume is up to the maximum.
Can you listen us better now?
How is that volume right now? Can anybody check on us? Maybe something with the OS. Can you handle with the mouse for a little bit? Input.
Okay.
I think we will need to go on like this. Maybe we're going to be closer
to the
and talk a little bit louder on the microphone, and then maybe rewinding the presentation once we update this video to our group on Facebook or YouTube channel. But yeah, let's continue with this. If you have any question, please let us know. Yeah, it's a big problem, but I think we are a little bit short of time. So the way to go is just talk closer and louder and continue like this. So Maria, go ahead.
Perfect. So the next step is integrate the application with Ubidots platform. So to do this, we have to go to the integration tab, and then we press add integration, select the Ubidots one, and assign a process ID. In this case, I'm going to assign SODAC uplink messages. I'm going to assign as access key the default key, and we have to assign our Ubidots token in order to start sending data to Ubidots, right? So to get the Ubidots tokens, we have to go to our Ubidots platform, go to the profile picture, select AppEUI credentials, and then you will have the token. Then just place it in TTN and press add integration. So at this point, once a new data is received in our device, a new device has to be created in the Ubidots site with the device AppEUI of the device which is handling the data.
That's correct. So I just want to make a quick comment there. So if you see right now, we have a new device created on Ubidots, and surprisingly, as Maria said, it's going to be with the same EUI identifier from TTN, and it's going to be the same on Ubidots. This is really nice because it allows you to simply untouch or unwire yourself from thinking on unique IDs.
Exactly. So you can manage thousands of devices, and you don't have to care about how you're going to handle these.
This is already done by the hardware provider. They give you a unique identifier as the EUI. So in this point, we are seeing data from the potentiometer right now.
So if we change the value here, you will see how the value is going to change when a new data is received. Also, we can assign here a friendly name in order to identify easier our device. So now that we are sending uplink messages to Ubidots from our device, then going to the Think network and then going to Ubidots, we're going to do the same but in the other way. So now we're going to send data from Ubidots to our device.
Great.
So to do this, we're going to handle a downlink messages. But the first thing that we have to do is create a variable, which is a variable who is going to send a specific values to our device. In this case, I'm going to use a relay, so I want an on and off status. So now that I create this variable, I have to create an Ubidots event, which basically send an action based on the behavior of a variable. So for create event, I press data, then go to the event section and create a new event. Here we're going to select the variable previously created, which is the relay one. Here we can verify if it's the right variable and then select it. So here, if the value of the variable relay is equal to 1, which means that it's activated, I want to send an action. So what are you going to do then? So the action is going to be the Things Network downlink.
Great.
Here, we have to assign some parameters provided in our TTN console in order to set our configurations. So the first one is the region. So we are going to assign the same region that we create in our application. Then we are going to assign the application ID, which can be found in the overview of the Things Network console of the application. So here you have it, application ID, AppEUI. So we place it here. Then the process ID. To the process ID, we have to create a new integration, a new HTTP integration, which can with a process ID. Let's call the same, but in downlink.
Downlink, yep.
Access key is the default key, and the URL HTTPS.
Which in this case, the URL can be anything right now. We just need we need this HTTP integration for the purpose of the TTN give us a new ID, process ID, a SODAC downlink message. So we copy that and paste it on Ubidots. Exactly, and then the application key from your application.
Overview of the application, and you will find it at the
end
bottom,
of the page.
Then the device ID. Our device ID, if I'm not wrong, SODAC 1B3. But anyways, you can find the ID of your device in the device section. You enter here and you can see device ID, SODAC 1B3. The same one. Then we have to assign the port. The port can be found in the downlink section here, as you can see. So it's number 1. We assign the same port here, and here you can set establish if you want to confirm the message when it's received or no. In this case, I'm not to confirm the message, and also TTN let the users manage different type of payload, which is a payload field, which is basically a JSON, or a payload raw, which is the data in base 64. In this case, I'm going to use the raw payload, and I'm going to fix the data that I'm going to say. So if my relay status is equal to 1, I want to send a 1, right?
Yeah,
so I'm going to send a 1 in base 64, and also I want to send a 0 when my relay change its status, so when it backs to normal. So here I can do the same. So trigger this action when the event condition goes to back the
Back to
normal
normal
state. Here I assign my device ID again, the port, and the payload route, which is the type that I want to use, and I fix the data 0 in base 64, right?
Yeah.
So now that we have both values, we're going to set our event, and here we have it. We can assign a friendly name to identify our event between like many events. TTN Downlink, and here we have it. So our firmware is already managing the uplink messages and downlink messages. So at this point, I'm going to create a dashboard really quickly. So here I'm going to assign a name, TTN and Ubidots. Then I'm going to assign a widget to see the variable that we are managing sending from TTN. Here we can change the range because for the resolution of the potentiometer. And here we can say, we can change the name if desired. And yeah, so then we have our value. So David, if you want, you can place the we have a demo here, so you can share with the viewers the demo are over there.
So guys, this is the hardware we prepare. This is a potentiometer which has a relay inside. I know you cannot see it. I'm going to show you in another camera, and we're going to connect a light bulb that is going to be switched from Ubidots. Okay. So we have it here.
So here I'm going to create the switch.
And before I electrify myself, oh my god, this is turned off. Oh great. And I need to switch this on.
Okay, so at this point, if David move the position of the potentiometer, you can see how the gauge change its value once the value is received, and also we're going to see the action of the relay using the switch widget, right? So at this point, I am going to schedule you a downlink messages by pressing this. So now if I go to the data information, you can see that a device was scheduled, and then once the first uplink message is received, the downlink message is going to be received in our device. So I'm going to do the same way, I'm going to schedule now the downlink messages to turn off the light. So just schedule a new message, as you can see, and
in just a few seconds, please remember it's like 10 to 12 seconds between message to message. So the next one, there you go.
Didn't have it, didn't get it. Downlink messages. Let's try it again.
Yep. That's weird. Okay, check on TTN, please.
So it sends the 1. So now we're going to send a 0. So here, the 0 was scheduled, and now here we have it, right?
There you go. We have our light bulb turned off and on from Ubidots. And I just want to point out that this was done in under 30 minutes. We have been in the Facebook Live for 30 minutes. So this was really simple to set up. Can you show them again how to turn it on and turn it off from Ubidots, just for demonstration purposes? While I say that we're going to have this guide ready for next week, so you can follow it. All the code is available for you guys. You only need a device to connect to TTN, some relay, and an Ubidots account, of course. And turn it off again.
So now that we finished, we have a coupon code.
A surprise.
A surprise.
You need to say surprise.
Ah, sorry.
You need to say we have a surprise for you guys. To everybody who's tuning in with us every Ubidots Facebook Live. Today with TTN, we are going to present a coupon code that you can input on your Ubidots trial, or if you're already paying a subscription, you can also use this coupon to, let's say, enable the white label add-on on your account if you haven't. And there it is. And we are behind it.
So you can claim it, and you have just 2 days to claim this coupon code. So feel free to claim it and share it with your friends and start knowing the platform. I know that you are going to really love it when you start finding that everything is too easy to do using Ubidots, because everything is just like clicking around the platform, and that's it.
So guys, I hope you got it. We're going to turn back to the camera just to say goodbye. We hope you like this session. We apologize for you for the sound problems. We hope we can manage it or strengthen the sound volume on the YouTube video.
Yeah.
We're going to try that, and then we are behind that. Wait,
no,
why don't we change it?
It's a lag.
It's a lag. So guys, if you have any questions, please redirect them to the support@ubidots.com. We're going to be really attentive to any doubt. You can also check the help center, that is help.ubidots.com. There are a host of resources with all articles on how to manage these TTN things and other stuff related to Ubidots or other devices using other connectivities, protocols. You can find,
all the resources that you need to start building your IoT application.
So, see you guys around and enjoy the hacking.
Bye bye, see you.
Bye bye.